In this lecture, we are going to discuss the topic the derivative. In the previous lectures, we discussed about two problems. First one is to calculate the instantaneous velocity, and the second one is to calculate the slope of the tangent line. In both the problems, the procedures are same, but the terminologies are different. The terminologies are depends on the particular context. So there we defined some term delta y by delta x, and it is called average velocity in the case of or in the problem of instantaneous velocity, and in the problem of finding the slope of a tangent line, this delta y by delta x is called slope of secant. Okay, slope of secant. Now we are going to introduce a new terminology for this type of problems, or this type of delta y by delta x, etc., which can be used in any situation. Okay, so for any function y equal to f of x, we are going to define such terms. Okay, so we can replace these terms average velocity and slope of the secant line by a term difference quotient. Difference quotient. So we can say we can call this delta y by delta x as difference quotient. And also in the previous cases, we used the limiting case of this delta y by delta x as a letter v or m. V is called the instantaneous velocity, and m is called slope of the tangent. Slope of the tangent. Now, in general case, we can replace these two terms by derivative. By derivative. Okay. So, to find how to find the derivative, and it is denoted by, for a function y equal to f of x, the derivative at a point x naught is denoted by f dash of x naught. Okay, so here we are going to introduce some terms which can be used in any context. Okay, rather than average velocity and slope of the secant, we can use difference quotient for delta y by delta x, and for instantaneous velocity, instead of instantaneous velocity or slope, we can use the derivative for this v or m. Okay, and is denoted by f dash of m. So to calculate the derivative f dash of x naught of a function y equal to f of x at the point x naught, first, we have to form the difference quotient, that is delta y by delta x, which is nothing but f of x naught plus delta x minus f of x naught divided by delta x. Then we have to simplify this expression by cancelling delta x if possible. Okay. Then the derivative of this function y equal to f of x at the point x naught, that is f dash of x naught, can be obtained by approximating this the difference quotient delta y by delta x for small values of delta x. Okay, so that is the method to find the derivative. This is actually the same method that we used to find the instantaneous velocity or slope of the tangent line, etc. Okay, so this operation is finding derivative is called the differentiation. That is, the differentiation is the process of finding the derivative of a function. Okay, now we can do a problem. Suppose that m is a constant. Differentiate f of x is equal to mx plus 2 at x naught is equal to 10. So here we have to find the derivative of f of x, which is equal to mx plus 2. It is a linear function. We have to find the derivative of this function at the point x naught is equal to 10. So since it is a linear function, we know the derivative is the slope of this function, that will be m. So our aim is to find f dash of 10, which is let me just show that f dash of 10 is equal to m. That will be the derivative of f at the point 10. Okay, that is the slope of this linear function is m. Clear. So algebraically, it can be obtained by using the method we discussed earlier. That is, first we need to find delta y by delta x, that is the difference quotient. Here f of x is equal to mx plus 2 and x naught is equal to 10. So delta y by delta x is nothing but f of x plus delta x, or f of x naught plus delta x, minus f of x naught divided by delta x. Since x naught is equal to 10, we have this is equal to f of 10 plus delta x minus f of 10 divided by delta x. So replacing the function f of x is equal to mx plus 2, we have f of 10 plus delta x is nothing but m into 10 plus delta x plus 2 minus f of 10 is m into 10 minus 2, right, divided by delta x. So this is equal to, we can cancel 2 and 10m. 10m is here, so we have m into delta x divided by delta x. So this is equal to m itself. So this is the value, that is the, this is the difference quotient. So as delta x approaches to 0, or as delta x is very small, we have the derivative of f at the point 10 is given by delta y by delta x. That is, as delta x is very small, we have delta y by delta x is m itself, because it is independent of delta x. So as delta x is very small, we have delta x is equal to m, and therefore dash of 10 is equal to m. Okay, so that we here we obtained the slope of this uh, or the derivative of this f of x equal to mx plus 2 is equal to m at any point. Here we used the point 10, that is, we find the derivative at the point 10. If we replace this x naught by any point, we will get the value m itself. So because it is a linear function, we know the derivative is actually is a slope. So slope is m. Here the slope is m itself. So at any point x naught, we have the derivative is nothing but derivative of this function is m. Clear. Next we have a quadratic function rule. Let f of x is equal to ax square plus bx plus c. It is a quadratic function where a, b, c are that the coefficient functions are constants. And let x naught be any real number, then f dash of x naught is equal to 2a x naught plus b. That is, the derivative of this quadratic function at the point x naught is nothing but 2a x naught plus b. Okay, so we can prove this proof of this quadratic function rule. Uh, Here we have to show that let f of x is equal to ax square plus bx plus c. We have to show that f dash of x naught is equal to 2a x naught. That is what is we have to show that. Okay, so first we can find the difference quotient delta y by delta x is equal to f of x naught plus delta x minus f of x naught divided by delta x. So this is equal to f of x naught plus delta x is equal to a into x naught plus delta x whole square plus b into x, that is x naught plus delta x plus c. This is f of x naught plus delta x minus f of x naught. That is, we can replace x by x naught here. So ax square plus b, so ax naught square plus bx naught plus c, right, divided by delta x. Okay, now this is equal to, expanding this we get a into x naught square here plus a into delta x whole square, that is delta x square plus 2 x naught delta x here into a, that is 2a x naught delta x plus b x naught will be here plus b into delta x plus c. Now this is minus a x naught square minus b x naught minus c whole divided by delta x. So we can cancel this ax naught square, bx naught and c. Okay, So the remaining part will be a into delta x square plus 2a x naught into delta x plus b delta x divided by delta x. So each of these three terms contain delta x. So we can divide delta x here. So we will get a into delta x plus 2a plus 2a x naught, right? 2a x naught plus b. Okay, so this is delta y by delta x, that is the difference quotient. So the derivative of the f dash of x naught, derivative of f at the point x naught is nothing but uh, the value of the difference quotient delta y by delta x, value of delta y by delta x as delta x approaches to 0. Okay, we know that as delta x approaches to 0, we have a delta x approaches to 0. So that thus delta y by delta x approaches to 2a x naught plus b. 2a x naught plus b. That will be the derivative of f at the point x naught. That is, it is denoted by f dash of x naught. Okay, so f dash of x naught is obtained by approximating delta y by delta x as delta x tends to 0, right? So this is 2a x naught plus b. Sorry, I made a mistake here. It is 2a x naught plus b. Okay. Next, we can do a problem by using this quadratic function rule. Find the derivative of f of x is equal to 3x square plus 8x at the point first one x naught is equal to minus 2 and the second one x naught is equal to 1 by 2. Okay, so we already discussed that the quadratic function rule, that is for a function f of x is equal to ax plus ax square plus bx plus c, we have the derivative uh, at the point x naught is nothing but f dash of x naught is equal to 2a x naught plus b. Okay, so we can use this. So here our function is f of x is equal to 3x square plus 8x plus 0. So here a is equal to 3, b equal to 8 and c equal to 0. Clear? So first we need to find f dash at the point x naught, that is minus 2. That is f dash of minus 2 is equal to, we have 3 into 2a x naught, that is 2 3, 2 into 3 into x naught plus 8 will be f dash of x naught. So replacing x naught by minus 2, we have 2 into 3 into minus 2 plus 8. So this is equal to minus 12 plus 8, that is equal to minus 4. Clear? So in a similar way we can find the second question also. We can do that. F dash of minus 2 is equal to, sorry, f dash of 1 by 2 is equal to 2 into 3 into x naught. X naught is 1 by 2 plus b. B is 8. That is 3 plus 8, that is equal to 11. Okay. Now we can rephrase the quadratic function rule uh, to get the derivative as a function of x. That is to find the derivative at any point of x. So that is the derivative of the quadratic function f of x is equal to ax square plus bx plus c is the linear function f dash of x is equal to 2ax plus b. Okay, at any value of x, we can define this quadratic function rule by this. Derivative of f of x is equal to ax square plus bx plus c as a linear function f dash of x is equal to 2ax plus b. Okay, as a special case, if we choose a equal to 0, if we choose a equal to 0 in this quadratic function rule, we get the derivative of f of x is equal to bx plus c is the constant function b, that is f dash of x is equal to b for this linear function. Now as a special case, if a equal to b equal to 0 in this quadratic function rule, then we get the derivative of f of x equal to c, that is the derivative of a constant function f of x equal to c is 0 function, that is f dash of x is equal to 0. Clear? Okay, now you try these problems yourself. Okay,